right. Okay, so on the left side, we're going to talk about characteristics of an exponential. And on the right side, we're going to talk about characteristics of a linear. Okay, they could give you two tables and ask you which one's exponential, which one's linear. You have to decide and tell you why. Okay, they could give you two equations. You need to decide. Okay, they can give you two graphs. So we're going to talk about the differences in each one of those. Okay, so a linear. A linear can either increase or decrease by what?
2.
How do you figure out the pattern?
You
You
add.
add or subtract. So a linear is an increase or decrease at a constant additive rate of change. Okay. So a linear, we can increase or decrease by an additive rate of change. What that's telling you is you add numbers along your y's or you subtract numbers along your y's. Okay. So you find your pattern by adding or subtracting.
Can I put increase at a constant rate?
So what time is that different for two then?
3:35.
What if we're like a little late?
For what reason?
Because I have to go let my mother know. Pick me up.
You should call her at lunch and let her know, or send her a text at lunch and let her know.
No offense, if nobody's here, just miss going to the doctor.
You go to the doctor?
I have to make an appointment.
So you're not staying for 2 days?
No, I'm staying, but if nobody shows up, I'm going to the doctor.
I'm coming. I'm showing up.
I'm showing up.
Hopefully not, because they don't have a project and they're testing today.
Oh, that's why.
Oh, yeah, because they waited till the last minute to do their chapter 4 project and they're
Oh.
struggling.
I feel
The
like
struggle
it
was
just-
real.
Okay.
It'll probably just be more of you guys than it would be any of them. Okay, so linear increases and decreases. Exponential. Okay, stop. Asha. Could have broke my toe. Okay,
Broken small.
so increase or decrease with an additive rate of change.
Increase.
Okay. An exponential also can increase or decrease, but how is the rate of change? What are we doing to change your y's? We're multiplying. So this is an increase or decrease at a constant.
Multiplicative.
You got it. Multiplicative, multiplicative, rate of change. MULT. Sorry, that's an L and a T. They're kind of like merged together. MULTIPILCATIVE. Multiplicative. Woo! Look at y'all using some smart math words.
And then outline.
What did they say?
Increase or decrease.
Can't see.
Yes, there should be an I between the L and the C.
Multiplicative.
Oh, I gotta breathe out. L-I. There we go. There we go. You're fine.
No, I already spelled it right.
Oh, did you?
Yeah.
Multiplicative.
Okay, so that is how you tell the difference in words, whether it is an exponential or whether it is a linear. Okay? Let's take a look at the graphs.
Miss Smith, what time did tutor end?
4:30.
Oh my God.
If you're riding the late bus, 4:45, because that's when the late bus
Well,
leaves.
is that okay?
Well, we can stay here until 5.
Yeah.
I told her 4.
I got new braces.
I don't know what we're gonna accomplish really in a half an hour,
You can
but
stay.
okay.
Till 5.
Okay. So when I'm looking at graphs, what does a linear graph look like?
Straight line.
Straight line. Okay. So you can have a linear graph that increases or a linear graph that decreases. Okay. Yes, I know there are linear line or vertical and horizontal, but we're going to look mostly at increasing and decreasing lines.
So basically you just grade them like how you read books.
Yes, you read a mathematical graph just the way you read a book, from left to right. So this line, as I go from left to right, it's going up. This line, as I go from left to right, it's going down. So that's your increase versus your decrease. Okay, your exponential graphs are going to look like this. Here's your increase. So they've got a curve to them because they're being multiplied, so they're going to shoot up faster than a linear graph. And here's your decrease. Okay, so they sort of look like a line, and then it's like all of a sudden they take off like a rocket. No, that's, you're getting into sine and cosine and all that funky stuff with the waves. Oh, yeah. Okay. Difference in equations. What was the form we used for a linear equation? Y equals
MX plus B.
mx plus b. Okay, I'm going to put plus or minus b. Because again, it all depends on where you start. You can start at a positive number or you can start at a negative number. Okay? So just because you get mx minus b does not mean it's not linear. So that could be a plus or a minus in between. So something like 1/4 x minus 2 would be linear. Okay.
Now for the exponential, I don't get x.
No, it's X.
I'm just waiting for all the individual conversations to stop. Okay. So an exponential, remember, is going to have initial value, which they call A. And that's going to be multiplied by your base, which is raised to an exponent.
It's like a function of
Hmm?
Is this similar to a function of addition? Can I give an example?
Go for it, TJ.
All right. Teacher, base, no, not the base. Initial 7, base 2, exponent 3.
We're just going to leave it as X because then I can tell you X is 3, and you would plug in 3 to solve it.
Wait, how? 7 times 7 or 7 times 2?
So if they told you that X was 3, you would plug it in like this. Raised to the third. Remember, order of operations tells you 2 to the third first.
With an 8.
So 2 times 2 times 2, which is 8. So then you'd have 7 times 8.
24.
Mm-mm.
And 56.
56. 7 times 7 is 49. So that's how you would solve it then. Okay, so with the exponentials, you cannot forget order of operations. That exponent has to come first. Order of operations will come back to haunt you every time. It will not go away. All right. What do these look like as a table? What you got, TJ?
Okay. First number. 3. Second number.
What are you giving me? Y's?
Oh, I thought you. Which are you on?
It don't.
Oh,
We
okay.
usually do linear
I
first.
thought it was a linear. Okay. On an X, I want to do 3. Then 0.
You can't do that. I need one spaced. So 3, 4, 5, 6.
I mean, you don't want no.
I know this is what I want. So,
2, 4, 6, 8.
and then you said 2, 4, 6, 8. Okay. So we find our pattern with a linear by adding or subtracting. So am I adding or subtracting this time? We're adding. What am I adding by every time?
2 and 1.
2 plus 2 plus 2 plus 2. And this is plus 1 plus 1 plus 1. So your rate of change or your slope.
2 over 1.
Yes. Your rate of change, which is your slope, is 2 over 1. Okay. Multiply or divide. Again, I want my x's to go up by 1. So let's do 0, 1, 2, 3. Go ahead, Husto.
7.
7,
14.
14,
28. Yeah, I know.
28,
I know. 3.
56. So plus 1 plus 1 plus 1. This needs to be multiplied or divided. So what's my pattern along my y's? Times 2. So my rate of change is to multiply by 2. Okay. My rate of change is times 2. Okay.
You go back up to the top, Lisa.
Yes, please.
We still have 2 more we got to do. Yeah, we need exponential and linear situations. Okay, so we're going to talk more about word problems tomorrow, but I want you to be able to identify linear versus exponential as a word problem. So, a word problem on the linear side would be something like, I babysit every week and get paid $50 a week. Okay. You babysit every week and you get paid $50 a week. So that means the first week you get $50. The next week you're up to $100. The next week you're up to $150. Okay, you're increasing at a rate of 50 every week. So that's what makes this linear. Your actual equation that would go with this is y equals 50x. Okay, because you're increasing by 50 every week, which means 50 is your slope. Okay. An exponential example would be something like, I have a loan on a car. I bought for $12,000. I pay 5% interest. Okay. So I have a loan on a car. You bought the car for $12,000 and you're paying 5% interest. Okay. So exponential, it's going to be on loans. It's going to be on savings accounts. It's going to be, most of the time when you see a percentage, it's going to be an exponential. Again, we're going to talk about more how to write these, but your equation for this as an exponential would look like this. No, it can't. Y equals 12,000, because that's my initial, that's what I paid originally. And your base is going to be 1.05 raised to the x. So this is the equation that would go along with this word problem. Can anybody figure out why my base is 1.05?
That's where 5% and regular numbers.
Okay, 5%, but why is that one there?
Because you pay one.
No, you can write a decimal all by itself. You don't tell us, please.
Okay, so you're paying interest. Okay, so that means you're paying over what the original was. So your original was always at 100%. You're paying 5% interest. So that means you're technically paying for the entire car plus 5, which makes it 105%. Written as a decimal is 1.05.
Big brain.
So you're always starting at 100%. If I tell you you're doing a 5% discount, instead of adding to that 100, you would subtract it, and that takes you to 95, so then you would use 0.95 as your base. So you've got to pay attention to, if it's increasing, you add it to that 100%. If it's decreasing, you subtract it from that 100%. So 1.14. So these are the types of problems with, like, I go into Hollister. The original shirt is $35. I get a 20% discount. How much do I pay on my shirt?
25.
Oh, I thought you said $100.
Okay.
That's all we're doing.